to today's class. We're looking at the third series of our sequence of classes on dimension. Remember that our base of measurement in dimension is MLT, which means mass, length, and time. As we look at these parameters, we want to find these physical quantities in relationship to mass, length, and time. We're looking at capacitance. Now, what is the formula for capacitance? Capacitance is quantity of charge over PD. Now, I'm going to find the quantity of charge by knowing that current I is equal to change in charge over the change in time. If I should put one here and cross multiply, this one will come to this side, while this one will go to this side. So I'm going to have that charge is equal to IT. Having said that, I need to find PD. What is PD? PD is work done over charge. Well, what is work done? Work done is force times distance. I need to know that the dimension for force is MLT minus 2 times by distance L. How do I know this one? I know that force is mass times acceleration, which means mass M times by LT to the minus 2 acceleration. If I multiply this one will become 1 plus 1 according to indices. This becomes ML2 raised to the power of 2 and T minus 2. Having said that, I need to know that we are not true. We still have that PD is equal to work done over charge. Work done, let's bring this parameter upstairs to this place. We have it to become ML raised to the power of 2 T minus 2, and then we're dividing by IT. As we're dividing by IT, you need to know that you will keep very careful because this is indices. We're going to apply indices here. This one becomes M, alright? This one becomes L to the power of 2. And then you need to know that minus 2 minus 1, that will give me minus 3. And then I have that I, when it goes up, becomes I to the minus 1. Having said that, I need to know that this is the parameter for PD. I'm going to bring it into this formula. Capacitance is now quantity of charge, which is IT. Alright? Divide by the PD. This is the PD. The ML2. And then T minus 3, and then I minus 1. I will need a space to put my answer now. So let's make a space. Let's use this up here. Let's use up here. So we're going to find out that this one, if it climbs up according to indices, it becomes M minus 1. This guy, if it comes up, it becomes L minus 2. And then we know that this is 1. Now 1, this is T minus 1 minus 3, that will give me 4. Okay, we have it to be 4. And then I have that I, 1 minus 1, that will give me that I is equal to the power of 2. Remember that why it is like that, let me explain to you what it means. When I say that 1 minus 3, this thing will cancel out, it gives you 4. You do the same thing, it's just 1 minus 1, it cancels out, so it gives you 2, it gives you 4. Hope you understand, that's mathematics. Alright, so we bring our relationship, we'll bring this into the box. So we have that M minus 1, we have that L minus 2, we have that T is 4, and we have that I raised to the power of 2. That is the dimension for capacitance. Now we're going for the dimension for torque. Now the dimension for torque is simply, we want to find the formula for torque. Well, torque is radius times by force. Well, radius is L, force is mass times acceleration. So radius is L times by MLT minus 2. Remember I got force to this side. So we're going to have 1 plus 1. This is ML to the power of T minus 2. So let's bring it in. Torque is ML to the power of 2, T to the power of minus 2. So what we're going to do now is that we're looking for the dimension L raised to the power of 2 t minus 2 all divided by time. Now, be very careful. Oh, that's, go for it. Now, what we're going to have as the dimension for power is m, now, L2, and then minus 2 minus 1, that is minus 3. Alright? That is minus 3. Let me put it there. Minus 3. So this is the dimension for power. So let's put it there, m, L2t minus 3. Now let's go to the dimension for impulse. Now, we need to know what is the formula for impulse. Well, we need to know that impulse is force times time. If you know that impulse is force times time, I will say that force is mLt minus 2 times by t. Now this becomes ml minus 1 plus 1. This is minus 1. So this is the dimension for impulse. Now we go to potential energy. We have space here, and let me see. So potential energy B. So BE, let me use a white chart. BE is equals to mass times gravitational force times by height. We don't represent these things in this parameter. Mass is still mass. Gravitational force, which is gravitational acceleration, is actually Lt minus 2 times by height. We represented the length. So what we have is that this becomes m 1 plus 1, that is 2, t minus 2. So what we have there, a potential energy becomes m L2t minus 2. Having said that, we go, that's potential energy, we go to energy. What's energy? If you look at that energy, you will find out that energy, electrical energy, is power times time. Electrical energy, E, is power times time. Have we solved for power? Yes, we did. We solved for power. This is over there, so we bring it to this place. It becomes that power is mL2t minus 3. We got power from there, then we bring it to this place. It becomes that times by t. Now, we look at it that this is minus 3 plus 1. This becomes mL2t minus 2. Alright, so that is the dimension for energy. So mL is the power of 2t minus 2. Now we go to gravitational force. Well, we have solved for gravitational force in our previous video, but we want to also use another method to illustrate that fact. We have solved it in our previous video, as I told you. We have also solved it in our question and answer series. We will still solve it again in another perspective, because you know that emphasis or repetition will make you to understand it more. But let's solve it another way. So we know that G or force is equals to Gm1 m2 divided by r to the power of 2. Now let's multiply by r squared. So we multiply by r squared. What you do on this side, you do on this side. What you do on this side, you do on this side. So r squared will cancel r squared. What you have is r squared force is equals to G m1 m2. We want to isolate this G. So I'm dividing by m1, m2. I'm dividing by m1, m2, so that G is equals to r squared force m1, m2. You need this. This is 1, this is 1. We add it together so that G is equals to radius times force m to the power of 2. Now the radius is length. It's equivalent to length. So we have that length is to the power of 2. Then for force, dimension for force is mLt minus 2. You should know that by now. So we're dividing it by m to the power of 2. Now let me reduce this equation. My new equation becomes 2 plus 1, that is 3, becomes mL to the power of 3, and then t to the power of minus 2. So I'm dividing by m to the power of 2. If I've done that, let me manage this space. This will be equals to, now 1 minus 2, that becomes minus 1. And then this remains L to the power of 3, and then this remains 2 minus 2. Let's check what we did. Okay? I think there is no problem. Everything is correct. Okay? Alright, so when we have done that, we'll bring this in here. M minus 1, and then L3, and then T minus 2. Alright, so this is all we've got for you in this video. We'll still continue in our dimension analysis. You can check out our playlist on dimension section, you're going to find a lot of questions that will help you in your high schools, in your colleges, during your examination.